all to another session of Concept at Fingertips. This is Vidya, physics faculty from Acharya coaching. So in today's session, let us see series combination of resistors. So in a previous session, when we learned Ohm's law, we said that the current through a conductor, it depends upon the resistance in the conductor and the potential difference applied. So we can connect the resistors in different combinations. Series and parallel are the two combinations, and in this session we'll learn about series combination. So let's see series combination of resistors. So there is a circuit diagram from NCERT textbook. So here we can see the three resistors R1, R2 and R3. They are connected in series combination. So how we will understand whether it is series combination? The other type of combination is parallel combination. How we can differentiate between the two, right? So here R1, R2 and R3. If you connect the resistors in such a way that one end of the resistance is connected to another resistance and the end of that is connected to another resistance and so on. Like if we have a combination like that, then we have series combination. So here from the figure we can see it is connected in series. So what other components are there in the circuit? Let's see. So we have an ammeter connected so that we can measure the current of the entire circuit, and a voltmeter that can measure the voltage between the X and Y points in the circuit. That means across the three resistor combinations. So we have a supply voltage here. We have a combination of four cells and a key. So the peculiarity of the series combination is that the current that flows through each component in a series circuit will be the same. So current through each resistor is same. Since there are no other branches in this circuit, we can say that this current will be same as the the current in the main supply. So the current through each resistor will be same, and it is given by the I, which is also the total current in the circuit. Potential difference across each resistor varies according to the value of the resistance. So potential difference across each resistor, let's see that. Let's denote it as V1, V2 and V3. So let's see, this one we can say as V1, potential difference across R1, and potential difference across R2 as V2, and that of R3 is V3. So it depends upon the value of the resistance. Now here in this circuit, we can see the voltmeter, right? The voltmeter is connected across the terminals X and Y. So if you measure the voltage across the voltmeter, it will be given as V. So V is given as the sum of potentials across each resistance. So V is equal to V1 plus V2 plus V3. Now, if we apply Ohm's law on each resistances as well as on the entire circuit. So this circuit, if you can draw it as an equivalent circuit where we can combine these resistances. So let's say all the three resistances can be combined together by an equivalent resistance, and we have the same supply voltage. So if we can do, this will be the total current and this will be the total resistance. And the voltage that is dropped across this resistance, we can take it as V. So on applying Ohm's law on the entire circuit, we can say that V is equal to I into R equivalent, which is equal to, again, what is V1? V1 is the voltage drop across R1, and by applying Ohm's law to the R1 resistor, we can say V1 is equal to I into R1, because the same total current I flows through R1. Again, what is V2? V2 is I into R2 plus V3 is I into R3. So effectively, we can say by cancelling out I on both sides, we can write R equivalent is equal to R1 plus R2 plus R3. This means that if we connect three resistors in parallel, their equivalent resistance will be sum of individual resistance. So equivalent resistance of a series connection, series combination of resistances will be the sum of individual resistances. Another point to note here is the equivalent resistance, the final resistance that we get, R equivalent, will be greater than any of the individual resistance. So we can use a series combination if you want to increase the resistance in a circuit. For example, if I have 10 ohms, 3 ohms, and 4 ohms connected in series, then the sum of R equivalent will be 10 ohms plus 3 ohms plus 4 ohms, which is equal to 17 ohms. And this is greater than any of these individual resistances.